Hello everyone. In this video, we're going to learn about pointers. Pointers play a major role in programming with C and C++ language because these are the language which provides low-level functionality with the help of pointers. We can access memory locations and modify the value stored in that location, or we can create buffer of blocks of memory and then traverse through each of this block and work with them. So ultimately, the concept of pointers is very important for using and programming with C and C++ language. In contrast to the native language like C and C++, managed languages like C Sharp and Java, you don't have to study pointers. But under the hood, there is concept of references. So we have to study pointers to understand the actual memory management, how actually the memory is managed in any of these languages. But here we are considering the languages like C and C++ because these are the native languages and we have to work with them to understand the computer architecture, how the computer works. So let's get started. So let's declare two variables and both of them will have type integer so that they will occupy 4 bytes of memory each. So let's create the first one which is of type integer, name it A. This will allocate 4 bytes of memory in program stack. Right, this is also a memory region, and then allocate the second memory, and this will also occupy 4 bytes of memory in program stack, and this is a memory region, right? So what is going on behind the scene of this program? Let's see. Suppose that we have the program stack like this, right? And note that we are considering here 64-bit systems in which the word size is of 8 bytes, right? So let's create blocks of memory. This will also have 8 bytes. This will also have 8 bytes. This will also have 8 bytes and so on, right? So the stack will grow downwards, right? And we have declared the first variable which is of type integer, and this will occupy 4 bytes. This will require 4 bytes to reside in the memory, right? So we have to divide the first block into halves, and the first half will contain this variable, right? So this is the region of A, and now this will also require 4 bytes and we have the space left here. So we have to allocate it for the variable B, right? So what we can say about the addresses, we have to keep track all of these memory locations with the help of some kind of address. So let's say we have the address of this block, for example, that's 2000, and now we have to access this B. How we can do that? We know that the block of memory in which the B resides, B is just adjacent to the block of A, which is of 4 bytes. So we have to plus 4. We have to plus 4, and this will become 2004. So we can say that address of A is 2000 and then address of B would be 2004. But what if A has the address like 4000, then we can say B will have the address of 4004. So now you can see that we have the difference of 4 bytes. We have the difference 4 bytes, right? So please note that it is not fixed location like 2000 or 4000. I am just talking here just for the example. So in reality, this address is not defined, but it is actually defined that the address of B will be the address of A plus 4. Why it is so? Because B resides in the memory just after A, and the size of A is also have 4 bytes, right? And note that if B is of size 8 byte. For example, if I change this like long integer, right, and this will allocate 8 bytes of memory, right, and that means this B will have require 4 bytes of memory to reside in this program stack. Note that program stack is also a region of memory. So what we can do that? So it will require the second half of this, but note that we have just block of 4 byte, so we have to leave this as blank. We have to leave this as blank. So let's erase this. This would be blank. And then we have to allocate this full block of memory, which is of 8 bytes for the variable B, right? The address of B will be the address of A plus 8 bytes. This is the 8 byte. So we have to plus 8 bytes. So this will become 8 and everything will become 8. So now you can understand how the memory is allocated for the stack variables, right? So stack is very efficient memory region, and it will automatically freed by the program when the scope will end here, right? In the later videos, we will also learn about stack and heap, how much efficient is stack and how much efficient is heap. And we will also learn about the flexibility of these memory regions, how they are actually managed. So let's print the address of A and B and see what we have predicted is right or wrong. So we have to print the address of A, right? And we have to convert it to long, and we have to convert this variable A into the address of this. That means we have to access the address with the help of this ampersand operator. And this is called essentially address of operator. We can access the location, right? We can access the address of this variable in the programming stack. Note that I'm converting this address to the long integer because we can see the address in integer form, not the hexadecimal form, right? If you don't convert it to the integer form, then it will print the address in the hexadecimal form. It would be little bit difficult to understand us, right? So we are writing here like this. So let's write the end line, and then address of B, right? We have to also convert it to integer and then access the address of B and then print, right? So let's compile it and run it. Now you can see that address of A is 72 and address of B is 60. So we have the difference of 8 bytes, but we have expected that the lower address will be of A and the higher address will be of B. So what we are mistaking here is that this is the higher level and this is low level, right? So we have to swap this or we have to reverse it, right? So I have just taken the example so that you can understand, right? So we have the difference between A and B. Address of A and B is of 8 bytes, right? So what if we have the type here is integer, this will allocate 4 bytes. Now what we can expect here is that now B can be fitted into this block of memory and this will be blank, right? This will be blank. This will be blank. Okay. And now this will get filled, right? And now the difference between the address of A and B will have of 4 bytes, right? So let's take the look on the compiled example. Okay. Now you can see that we have the difference between the address of A and B of 4 bytes. Here it is 72 and here it is 68. And if you plus 4 byte into the 68, then we will get 72. So this is how the memory allocation works in the C and C++ language. And we can also modify the values on these addresses. For example, um, we will need a way to store this address, right? So we have to declare pointer, right? So we have to mention the type of which this pointer is gonna point to the memory block, right? So this will be of type integer, and then we have to mention here that it is of pointer type. That means it can hold address of this memory block type, right? So let's a ptr equals to address of a, right? And likewise we can also write like this, a ptr equals to address of b. And note that it is not necessary to put this star or asterisk sign is here, but we can also put here, right? Okay, so let's modify the value of a and b with the help of pointers. Before doing that, we have to initialize it. It is not compulsory, but for the testing purpose, we are doing here. Okay, now a will have the value 10 and b will have the value 20. And now let's change the values with the help of pointers. We have to dereference this pointer. That means we have to access the memory value and then change the value like 45. And now we have to access the memory block with the help of dereferencing the bptr equals to 100. Then what we are expecting here is that a will have the value 45 and b will have the value 100. So let's here print value of a is a and line, and then value of b is right. So let's compile and see what happens. Now you can see that we have got the result as we have expected, which is a has the value 45 and b has the value 100, irrespective of what we have initialized here, right? So this is much more like references in C# language or Java language, and this is how pointer works. And we will learn more about pointers, how we can manage memory much more efficiently, how we can work with buffers, memory buffers, and strings to manipulate and process strings, which would be gonna very complex, and how to write efficient code with the help of pointers. So if you like this video, hit the like button and then subscribe to my channel for the further updates. Thank you.